79. This is again a question that does not use a calculator. But we're given the graph of a function consisting of 3 line segments shown above. The function is defined on the closed interval, so that's going to be an important piece. On the closed interval 0 to 6, and then it says let g of x equal the integral from 2 to x of f of t. Now, whenever we get an integral expression where one of our points, or one of our endpoints is x, remember we call that an area function. And that's going to help us find the area under the curve from 2 to any other value on the interval. Then the actual question here is saying what is the maximum value of g of x between 0 and 6? If it just says maximum and doesn't give relative or local, that's an indicator that it's an absolute maximum. And when we have an absolute, we know we're going to have to make a table of values because we have to test our potential places where that maximum can occur. So what I'm going to do is I'm just going to start a table here, x and g of x. And in this table, I'm for sure going to put the endpoints 0 and 6 because those are potential places where that maximum could occur. The other spot is, so at our table of values, we test endpoints and we test critical values. Now to get a critical value, we're looking at where is g prime of x equal to 0. Well, we're given a graph of f. So the question is, what's the connection between g prime and f? And that comes to the second part of the fundamental theorem of calculus. If I take the derivative of this area function given, g prime of x is going to equal f of x. Because the derivative and the integral undo each other. So that means what I'm really looking for is I want to know where f of x is equal to 0. And since I have the graph of f, I can find that that critical point is at 3. So that gives me the third value in my table. Now it's at one of these points where this area function is going to attain its maximum. I just need to test all of those points. So I'm going to start with 6. Start with that one. So I'm looking for g of 6. If I want to find g of 6, that means I have to find the integral from 2 to 6 of f of t. That means I need the area under the curve between 2, here's 2, and 6. So to do that, I'm just going to actually do a little bit of work on this graph before even evaluating this and say, maybe I should just chunk this into pieces where I can find the area of all of these. And I can easily break it into a couple squares and 2 triangles. And they're of equal size. So each of these squares is 4. But this one down here I'm going to mark as -4 because it's below the x-axis. In between 2 and 3, this is a triangle of area 1 because we do 2 times 1 times a half. And down here we're going to get a -1. So if I want to find the area, so back down to this g of 6 equation, if I want to find the area from 2 to 6, I'm just going to add those 3 numbers up. 1 plus -4, or 1 plus -1 plus -4, and that gives me -4 for my value at 6. Now I'm going to do the same thing for the other 2. For g of 3, I'm going to look at the integral from 2 to 3, excuse me, of f of t dt. And for this one, that's just that triangle. That's a 1. And then the next one, g of 0, that gives me the integral from 2 to 0 of f of t. Now that seems a little weird because those endpoints are in opposite order. So all I'm going to do is I'm just going to switch them up and go 0 to 2. On the graph, from 0 to 2, it's +4, but I'm going to make it a negative. So that becomes 0, or -4 as well. So g of 0 is -4. I now look at the highest value out of all of these g of x values, and it's a 1. So that's the absolute maximum on the interval 0 to 6.